Hi guys, welcome back to my YouTube channel, Let's Crack Real Math. My name is Viraaj, and in this video we'll be having a look at similar triangles and how we can solve for them. So before we begin, please do perform an LSS, that is like, share and subscribe, and without further ado, let's get started. So before I go into some examples, let's see what I mean by similar triangles. What I mean by similar triangles is simply that, suppose I have a triangle here. I now have a slightly bigger triangle in the same shape. Let's say, okay, somewhere there. And I have my sides, the length of the side. Let's say this is x, this is y, this is z, and then let's say this is a, this is b, this is c. Now all these lengths may be different from each other, but what determines that a triangle is similar to another triangle is the angle which they create. So this angle would be exactly the same as this angle over here. This angle over here would be the same as this angle over here, and this angle over here would be same to this angle over here. So if two triangles have the same angles being made from the same sides, even though the length of the sides are different, that means that those two triangles are similar, because one of the triangles simply, you could say, an enlargement of the other. So that's basically the ground foundation on similar triangles. Now then the question arises is how you can find unknown sides, because in most cases they would give you, since we have three lengths over here and 3 lengths over here, they would probably give you 4 in total, and they would expect you to find 2 of them, or they could give you 3 in total and expect you to find 3 unknown lengths. So let's look at our first example. Right, so the first example I have 2 triangles. Again, before I start attempting, it's good to mention that all the similar triangle examples and all similar triangle questions are not to scale. Not to scale. What this simply means is that they are not made according to drawing, so don't take a ruler and start to bisect a triangle. Even if the 2 triangles may not look exactly the same, you should still know that if it's related to similar triangles, and if the question states it is similar triangles, then you treat it as similar triangles. It's not to scale, so you do not go into the drawing or measurement of that question. Now I have 5 here and x here. We can say that this side, this length on this side is the same as this length. Of course not in terms of value, but in terms of corresponding. We have y here and 6 here, we have 2 here and 3 here. Now the trick in solving similar triangles is you want to set up 2 fractions equated to each other. So what I would do first is I would take the 2 known sides I know of the triangle. We know that the 2 over here is simply the 3 over here. What I mean is that this side of the triangle, this side or this side, that side is represented by this side on this triangle, and both of those values are given, 2 and 3. So I can take the smaller one, I can say basically I have 2 over 3. Now that I have one fraction, I need to form another one. Let's start by solving for x. I know that this length, this side of the triangle, which is 5 for this triangle, is the same length as this side over here. It's represented by this side over here, and in this case it's x. So for this I could write, since I put 2 over 3, I took this triangle first and put it as a numerator. I have to take the 5 over here as well and put it as a numerator. So 2 over 3 equals to 5 over x. So simply you could have done this the other way around. You could have done 3 over 2 equals to x over 5, you would end up with the same answer as you would get now. But the key is that whenever you write it in fraction form, it's one side of that triangle to the other side of the triangle. So one of the side is the numerator and the other side is the denominator. And then when you're equating it to any other fraction you've made, which in this case is 5 over x, you need to make sure that your numerators are from the same triangle. So we know that the 2 and 5 are from the same triangle, and you know that the 3 and x are from the same triangle. So now that we have something like this, all you have to do is cross multiply. We know this is 2x equals 15 because 2 times x is 2x and 5 times 3 is 15. And using algebra, you know x is 15 divided by 2, which is nothing but 7.5. And now that you have your x, we can now solve for y. Actually, we don't even need our x to solve for y. Since we already have one fraction that's known for both the sides, we can use that again. We can do 2 over 3, but this time equate it to using y and 6, because we know that this side of the triangle is represented by this side of the triangle. And since as our numerator is 2 and our denominator is 3, so the numerator is from this triangle here and the denominator is from this triangle here, our numerator on the other side will also be from this triangle on the left, which is y, and our denominator will also be from the right triangle, the triangle on the right side, which is 6 in this case. So again, doing a cross multiplication, you know this is 3y because 3 times y is 3y and 2 times 6 is 12. Y is nothing but 12 divided by 3, which is 4. Please don't forget to put the units that you are working in. In this case, there are no units, but if there are, please make sure that you write down your units. Now, the second method to solve this question, which you can use to confirm your answer, is simply taking a scale factor. What this simply means is that since we know there's 2 over here and 3 over here for this triangle, we need to know what has been done to this 2 to get 3. In order to do that, we do 3 divided by 2, which is 1.5. So we know that in order to get 3 in this occasion over here, we had to do 2 times 1.5, which eventually gave 3. That means to get our x, we would have to take the corresponding side of that triangle, which is 5, and times it by 1.5 as well. So 5 times 1.5, and that would give you 7.5 as well. And now that we need to get y from 6, we know that in order to get 2 from 3, we divided it by 1.5, so simply do 6 divided by 1.5, and that would give you y as 4. So as you can see, both the methods are correct, and the latter method can be used just to confirm your answer once you have gotten your final answer via the first method. On to the next example. Right, so let's just get rid of this here. Okay, again, not to scale. Please take note, not to scale. Now in this case, both our unknowns, that's y and x, are on the same triangle. We know that this 10, which is represented by this side of the triangle, is corresponded or related to this side of the triangle, which is represented by x. We know that this side of the triangle, which on the left one is represented by 11, is related to or equal to this side of the triangle, which is represented by y. And lastly, we know that this side of the triangle, which is represented by 6, is equal to this side of the triangle, which is represented by 9. So let's see how we can go about this question. We have two known variables, that is 6 and 9 on corresponding, because we cannot use 11 to y first or 10 to x first. We have to choose one of them, but we know that 6 over here is simply 9 over here. So our first fraction we have is 6 over 9. Now that equals to what? Again, you can take two corresponding sides, so this would be, let's take 11 and y. Let's solve for y first. So 6 over 9 is equal to 11 over y. Now make sure that both your numerators are from the same triangle, 6 over here and 11 over here, and the denominators are from the same triangle as well, that's 9 over here and y over here. And please make sure that whatever like suppose the numerator, whichever denominator is over, it's from the other triangle. So 6 is not over 11 but over 9, because that's from the corresponding side on the other triangle. So cross multiplication, we know this is 99, because 11 times 9 is 99, equals to 6y, because 6 times y is 6y. And we know that y is 99 divided by 6, and that is 16.5, if I'm not wrong. Let's just quickly check that in the calculator. 99 divided by 6. Yep, 16.5. Let's check that again. 16.5. So we have our y. Now we need to find our x, which is here. Again, we can use the known side we have, that is 6 over 9. So we can do again 6 over 9. And this time equate it to, rather than 11 over y, we can do it to 10 over x, because we know those are the same corresponding sides. Again, make sure that your numerators in both the fractions are from the same triangle, that's 6 and 10, and the denominators from the same triangle as well, which is 9 and x. So cross multiplying again, we have 6x equals to 90, because 9 times 10 is 90. X is 90 divided by 6, which is nothing but 15. And that is the answer for that question. Now if you want to check it again, we can see how we can check it. To go from 6 to 9, we had to times it by 1.5 again. So 6 times 1.5 would have given me 9. So in order to get y, we must have done 11 times 1.5. So 11 times 1.5, and that would give me 16.5, which I think I got as my y. Yep, I did. And then that means to get my x, I would have done 10 times 1.5. So 10 times 1.5, and that would have given me 15. Yep, so that is also correct, because that is our x that we found in the end. So that is the answer to that question. Right, so on to the next one. Question number 3. So this one, I only have one triangle, but we need to bisect this triangle in order to get the others. We know from this point to this point is 12. From this point again to this point, from here to here, is x. From here to here is 14. From here to here is 6. And from here again to here is 18. If I were to look at this, of course this y over here might confuse you a bit. But if I were to make two triangles out of this, I would have something like this. Suppose this is the big triangle that we are using. This is the big triangle. And I could extract this triangle out of it, this part, or this part over here. So I would now have something like this. This would have been 12, this would be 18, and this would be y down there. So what I did is I simply took the top part of the triangle, which starts from round about here and ends over here, and kept it separately, and now I'm comparing this small part as it is to the whole triangle that I have on the left. So let's compare them. Okay, this was x. Okay, and this was there. So let's compare them. I know 18 plus 6 for the whole of the big triangle is 24. So we know that this side of the whole triangle is 24. And I know that the same corresponding side, which is all of this over here, is the same as the 18 that's over here. So my first fraction I would have is 24 over 18. Now what does that equal to? Our numerators on both the fractions should be the same. So to start with, let's take 14, because I know that the 14 over here, which is represented by this length over here, is the same as the y that's here, but then represented over here as I extracted the smaller triangle on top out. So I will now have 24 over 18 equals to 14 over y. And of course the numerator on both the fractions are from the same triangle, that's 24 and 14, and the denominator is also from the same triangle, that's 18 over here and y from here. Cross multiplication, we know 24 times y is 24y, which equals to 14 times 18, and if I'm not wrong that's 252. Let's just quickly check that. 14 times 18, yep, 252, and y is 252 divided by 24, which is 10.5. So your y is simply 10.5. Now let's go to find our x. Now again we can use 24 over 18 because those are the two sides that we know, 24 over 18. But what does this equal to? We know that this side of the whole triangle from the top till the bottom is represented by the 12 over here. And all of this from here to here is simply represented by 12 plus the x that we have over there. You might not see it because I have scribbled a bunch of lines. Yep, that x over here. So the whole of this is simply 12 plus x. So we now have 24 over 18 equals to 12 plus x all over the 12, which is over here. 12. Again, why 12 plus x? Because this whole length over here is represented by 12, and then x, which we're trying to find for. So again, cross multiplication, 24 times 12, that's 288, equals to 18 times 12, that is 216 if I'm not wrong, plus 18x. 18x is 288 minus 216, which is 72. X is nothing but 72 divided by 18, which is 4. And that is the answer for that question. So on to the next example. Again, you can verify your answer with the second method. I won't do it for this question because of time, but you can always check your answer with that. On to the final example for this video. So I need to find x, that's here, and I need to find y over here. This is a challenge question. So please do pause the video and have a go at this by yourself, and then resume the video to see if you are correct or incorrect. If you are incorrect, please take note of your mistake. So I know that they represented a right angle over here, so automatically I have a right angle over here. This is 8, this is x, this is 10, this is y. Now if you look at this question carefully, you can see that it's not structured in a proper way. Although we have the right angle here, we know this is the hypotenuse over here, and you know the hypotenuse for this right triangle is here. So we already have 10 over y as one of our first fractions. Again, why 10 over y? Because we have two right angles here. The side opposite of the right angle is the hypotenuse, which is y over here, and which is 10 over here. So they represent the same side of the triangle. So we have 10 over y. Now what we need to look at is what other two values we can take. Is it 8 over x or is it 8 over 6? If you compare the two triangles, let's say this is one triangle from here to here, and this is another triangle from here to here. So you have something like this, and you extracted the other triangle to get something like this. Okay, yep. We know that both this is a 6 as represented over here. This is your y, this is your x, this is your 8, and this is your 10. So I've just separated the two triangles to make it look more easy. As you can compare, they're not in the same formats like we've seen for the other triangles, but as you know, if we slightly tilt this triangle anti-clockwise 90 degrees, this would become something like this. And there we go, something like this. The right angle was there, it will now become over here. The hypotenuse would still stay your y, this would now become your 6 over here, and this would become your x. And as you can see that now it's in the same format, you can now compare properly what is what. So as we took 10 and y over here because they're the two hypotenuse, let's take 8 and 6 because they're the two knowns. If I were to take 6 and x, I would have x separately and y, and I couldn't have solved the question because I would have two unknowns. So I would take equals to 8 over 6. Again, numerators from the same triangle, 8 and 10, denominators from the same triangle, y and 6, and one fraction is from opposite ends. So 10 from this triangle against the denominator, that's y from this triangle. 8 from this triangle against the 6 from that triangle. So solving for y, again, cross multiplication, you have 8y equals to 60. Y is 60 divided by 8, which is 7.5, if I'm not wrong. And let me just quickly check that. 60 divided by 8. Yep, 7.5. Now, using 8 and 6, since we already know that, 8 over 6, we can now attempt to find x, which would now be simply 8 over 6 equals to 6 over x. So again, cross multiplying, you have 6 times 6, that's 36, equals to 8 times x, which is 8x. X is 36 divided by 8, which is, I'm sure, 4.5, and it is 4.5, yep. And that is the final answer for that question. As you can see in this question, we had to separate the two triangles out. It may look complicated at first, but you can see as we got something like this, it became much easier then. So thank you for watching this video, guys. Hopefully you enjoyed it. Please do perform an LSS, that is like, share and subscribe. And thank you for watching, guys. Have a nice one.